Hello, G, am I audible? Just a second. Ji, Assalamu alaikum. Where were we? Yeah, am I audible? Can someone please let me know if I'm audible? Hello. So there are a bunch of questions. Let's just solve these. Okay. Okay, so the first one is the random variable takes on these values with these probabilities respectively compute the expectation of the random variable. So guys, how do you think we should proceed? I need someone to answer.
We'll just use the formula.
What formula? So, I mean, the definition, sure. So that's basically gonna go right. You have these three realizations of the random variable, right? And the PMF or the probability in simple terms is just 1 by 8, 2 by 8, and 5 by 8, right? And just a second. Did I? Okay, no, fine. Yeah, oops. So for the people who are here, we're trying to solve these questions, right? So the first one is that a random variable takes on these values with these respective probabilities, compute the expectation. So initially, I just want to solve it like this, that your random variable can take on these three realizations, and the PMF, or just the probability, is just correspondingly 1 by 8, 2 by 8, and 5 by 8, right? And now I want to find out the expectation. How would that go? Guys, if it's really difficult to talk to the like camera, so I need some
Uh,
people
is it 1/2?
conversing with me.
Like we'll
How?
multiply the
Yeah,
values for x by PMF values, corresponding PF values, and then we'll sum it up.
yes, precisely. So you have 0 and then 2 by 8 and
So it'll
plus
be one
1
by
and
two.
2. Precisely. So that's just minus 1 by 8. This is 0. So you get like 5 by 8, and that's just 1 by 2, right? Okay, good. Give the PMF of, so one thing I should do here as well is that I should also talk about the random variable y in my table. Okay, so my other random variable is y is equals to x squared, right? What possible values can it take? Well, when your x is minus 1, my random variable y, which is this, becomes 1, right? And
So do you want 0, 1?
correspondingly, yeah,
I'm saying the values for y, would they be 1, 0, 1?
yeah, 101 precisely. And okay, good. So the now I want to talk about the PMF of y squared, x squared, sorry. How would that go about? So for the PMF, it can only take 0 and 1 values, right? And the PMF would be, PMF or probability would be for 0, well, that's just what? 2 by 8, right? But for 1, now what it is? It's 1 by 8 plus 5 by 8, which is just 6 by 8, right? You add these up
Sir, can you please
because,
explain this?
well, your random variable is x squared, right? So whenever you get x
Yeah.
equals minus 1, the realization equals minus 1 or plus 1. In both cases, you will get 1 because these are the only values. It's a squared function, so it can't take negative values, right? Hence, you
Yeah.
add up the probabilities because when you get x equals negative 1, right, you get
Yeah.
y equals 1. For x equals positive 1, you also get y equals 1, right? So you add
Hmm.
both of those values, the probabilities correspondingly, and that gives you 6 by 8. Is
Hmm.
that clear?
Yeah.
Okay,
Yeah.
good. All right, so use it to compute e of y. Well, that's just 2 of 8. E of y is just 2 by 8 into 0 plus 6 by 8 into 1. So that's just 6 by 8, which just simplifies to 3 by 4. Is that clear?
Yes.
All right. Compute e of x squared directly from an extended table. Well, this was my extended table. It's a pretty simple question. So the C part would simply be 1 times 1 by 8. Now I'm using now I'm using this table to compute e of x squared. First, I was directly computing it from this table over here, which was just the PMF of y, right? So you had realizations and their possible, like their corresponding probabilities. Here, I'm going to use the PMF of x to compute the expectation of x squared. So that's just 1 by 8 times 1 plus 0 times 2 by 8 and plus 1 times 5 by 8. Not surprisingly, the answer is again going to be 6 by 8, which is just 3 by 4. Okay.
Sir, I don't understand how is this different from how we computed this in part B. वहाँ पे भी तुमने टेबल यूज किया सिर्फ वहाँ पे y की वैल्यू
वहाँ पे
0 1 है
आपने
यहाँ पे
so
-1 भी है
okay, there
हमारे
you
पास
use the yes, so there you use the PMF table of like the PMF of y explicitly. Here you used this table. That's it. I mean, sure. I mean, I get what you're trying to say. That I mean, it's just that you just 1 by 8 plus 5 by 8 you just wrote here, right? It's just a different mechanism, you can call that, or something like that. But that's about it.
okay
Okay. Here you
yeah
directly use the PMF. Here you didn't. Here you use the PMF of X. That's what I'm trying to emphasize.
okay
Okay. All right. So let's just clear this out. Other people are also welcome to speak. So this is a fun one. So suppose I play a gambling game with even odds. Okay, so I wager B dollars and I win, sorry, and I either win or lose with B dollars with probability zero point 0.5. So the idea is this. Let's say I go to a casino, okay, and I say that, you know what I'm gonna do? I'm gonna bet $1, okay, If I win, then obviously I get $1 more than that. So I get $2, right? And the probability is that I'm assuming that I will win half of the time. Okay. So what I do is now I say, I want to earn some money. So I'm going to go to a casino and then I'm going to give them my money. All right. So I'm going to bet $1. If I lose, I'm going to double my amount. So so from $1, I'm going to go to $2 and then bet again. And then I'm going to continue, keep doing that until I win some money. I will basically just earn like $1. Do you understand how I will win $1 eventually? So let's say I bet on the first game, right? The probability of me winning is zero point 0.5. So I can either lose or I can win with probability uh, or win with probability zero point 0.5. So I go, I place a dollar of, I place a bet of $1. Okay. Now what happens is that assume that I just win. Obviously, if I win, I'm gonna get $2. So I betted $1, I got one, which was my initial investment. And then from that, I just subtract two, and that's just I get $1. Assume that I don't now this was the attempt where I won, like मैंने $1 कमाया और पहली गेम ही मैं जीत गया, right? However, it could also be the case that I don't win, right? So I place $1, I lose. So I'm going to lose $1, right? And then I double that initial amount, that the doubling the initial amount would be, I now bet $2. And let's say I win this particular game. So when I bet $2, what am I going to get? If I win the second game, I get $4, right? But initially I had lost $1 on the first bet, and this was my initial investment. So I win like two plus one, $1. And I'm guaranteed to win this amount no matter how many times I play. You can imagine that on the first one, I bet this. Even if I lost the second one, then I would have doubled this. So then that would be one, two, and four, right? And then if I win on my $4 bet, I was gonna get $8. So I subtract from it eight, four, two, and then one, and that's just $1 net. I mean, seems like a very, I mean, there's not much reward in the game, but it's a good exercise to, I feel that to understand what's going on. I mean, if this is the case, then you may be able to, find a cheat way into like casinos might run out of money if you employed this technique, right? And obviously, there must be something wrong with this technique. Hello.
Yes, yes, sir, I can hear you.
Yes. So is the point clear or not?
Yes, it is.
Okay, good. So the question then asks you, if this really works, casinos run okay, etc. Let X be the amount of money bet on the last game, the one that I win, right? X takes values these, right? So 1, 2, 4, 8, and so forth. Determine the probability mass function for X, that is find P of 2K, where K is this. So what does this simply means? Well, it's asking you to find the probability that my random variable takes on the value 2K. What are Ks, by the way? What does K denote here? Can anyone tell me?
The number of times the game is played.
You're close, but no. It's the number of losses before the first win.
Okay.
Is that clear? So let's say if I take k equals 0, well, that would just mean that I won my first bet, right? So x equals 2k, well, this random variable is the amount of money that I win, right? So on my first game, I'm gonna win 2 raised to the power 0, right? And that's just 1. I'm gonna win $1, right? If it were, let's say, 2, k equals, sorry, 1. So that would mean that I lost the first game and then I won the second game. So I will substitute x equals 1, sorry, k equals 1. So I won $2, right? In the second game. Is that point clear?
Yes.
So x, your random variable, is the amount of money bet on the last game, right? The one that you win. Okay.
Yeah.
Okay. So what would that be equal to? Well, it's 50-50, right?
Yes.
Okay. So if it's 50-50, well, that would just be the number of times you lose, like the probability of the number of times you lose. You lose. Okay, hold on. Clarify that. Probability that the number of times you lose times the probability that you win your first game, right? Right? Is that point clear? It's literally like all of these bets are independent of each other, right? Because they are independent, your probabilities are just basically half times half times half times half times half, right?
Yeah.
Okay. But K donates what? The number of losses before the first win. So what is this thing over here? That's just half raised to the power K, right? This is the probability that you lose the first K games times the
Yes.
probability that you win the next game. So that would just be x equals 2k. This is it, right? What is this equal to? I'll just 1 over
Two. K
2k
plus
plus
one.
1. Yes. So that is my PMF, right? And you can check. So let's say if I take k equals 0, then this just gives me 1 by 2, right? Well, sure. If my k is 0, I win the first game. What's the probability of me winning the first game? That's just half, right? However, if it were, let's say, k equals 1, then the probability of me winning is what? 1 over 2. K is 1. So that would just be 1 plus 1, which is just 1 by 2 to the 2, 1 by 4, right? This is the probability that I win the second game. Is that point
Yes,
clear?
sir, I have a question. Yes,
Yeah,
sir, I have a
please,
question.
please.
They asked us to find 2 raised to power, probability of 2 raised to power k. तो k की तो समझ आ गई,
Yes.
it's number of losses before the first one. So what's this probability? Find 2 raised to power k wali.
No, this is the problem. This is basically P of 2K, right? This is this. This is just, don't you remember? So let's say if we used to talk about probability of, let's say, 1, well, that was just the same thing as saying that my random variable takes on the realization one, right? These are identical to each other. So what I've
Yeah.
done is probability of 2k is the same as the probability that my random variable, which is the amount of money that I won in the last game, equal to 2k, right? And
Okay.
this is equal to this. So
Okay.
one, your
Okay.
PMF is
Okay. I get
just,
it. I
yeah,
get it.
you get it? Okay, good. All right. So my PMF is, my probability mass function is 1 over 2k plus 1. Okay, good. Let me clear this out and let's just start again. So now I want to compute the expectation. Well, that would just be k equals 0 by definition till infinity. What? 2 to the k, because that is the realization of my random variable, right? Times the PMF. Well, that's just 2k plus 1, right? Is that point clear? This is my PMF, and this is the realization of my random variable.
Yeah.
Just like we did here, right? On the on the first here, we had like -1. So what was happening here was that I was just summing those up, right? So -1 times 1 by 8, right? So this was what? Probability that my x takes on -1, the realization, which is this
Yes.
thing over here, 1 by 8, times the x equals 1. Sorry, x equals -1. And I should also specify -1 here. Yeah. And then you add on probability of x equals 0 times x, like the value of that, which is just 0, and so forth. And exactly in an identical manner, I'm doing this over here. Is that point clear?
Yeah.
Okay. What was that? Yeah. Are you starting to see the problem with this? Can anyone spot a problem? Let me just simplify. K equals 0 till infinity. So you have 2 to the k. I can write it 2 to the k over 2 to the k times 2, right? This thing I can always write it like that. And this just means k equals 0 till infinity, 1 over 2. What is this equal to?
Infinity.
Yes. I'm guessing that you guys have seen this. So basically, it's like this. K equals 0 till, let's say if you had n, this is equal to n, okay? And you
Yeah.
might, yeah, because normally what happens is you have something inside. So then you add those up. So it becomes, sorry, I should not, it should be k, right? Normally you have something like this, and then you add those up. So that's just a1 plus so forth. But here, it's just a fancy way of representing n is just k equals 0 till n in terms of its constituents, which, like summing the values. So, yeah. Does anyone have any questions? Please feel free to ask. Okay, let's just go ahead. So that's just infinity. C part, undefined or infinity, whatever you want to call that. Use your part in B to explain why the strategy is a bad one. Well, you can do that to win $1, but you need, on average, infinite amount of money, right? That's a problem with this. You're guaranteed to win a $1, but you need infinite amount of money to do that, which does not exist, obviously. Is that point clear? No, yes. Because my expectation is infinity, right? This turns out to be infinity. So I need infinite amount of money in the bank to pretty much win $1. Yeah. I want to quote what I exactly wrote. Yeah. Since the average last bet is infinite, because that is what my E of expectation of X is, I need to have infinite amount of money in reserve or in the bank. Yeah. So I'm gonna go to next question. This is, by the way, uh, I think it's called Peterburg, something like that, paradox or something like that. You're free to look it up. Okay, let's go to problem number 3. Anyone want to take solve this? So you have joint PMF table. I want to construct that, right? And I also include marginals. So how would I go about it? What is this? Well, when my x is -2, what is the probability that I get y equals 0? 0, right? So, okay, let me explain the question first. You have a random variable which takes on these values, each with probability 1 by 5. And then you define another random variable which is just the square of the random variable x. And now I want to find out the joint probability distribution. Okay, joint prob probability mass function, right? So I have x values here, the possible realizations, the y realizations. Obviously, y can't take my -2 because it's the square. Okay. So now I want to write the probabilities of the joint distribution. So what this means is here at each of these values, so for example, for a specific, let's say this one, I want to talk about this probability that x takes on the value -1 and y takes on the value 0. This is what this entry means. Okay. Hello.
So this will be 0 as well, right?
So you have a 0 here and a 0 here. Good.
0,
What is this? 1
1.
by
This
5.
will be 1.
1 by 5, right?
Sorry,
Because
1 by 5.
everyone, yeah. Then x equals 1 and y equals 0. Well, that's just 0 and then 0, right? Because it can only take on the value 0 with 1 by 5. For all the other values, you don't get y equals 0, right? For the other one, what would this be equal to? Well, you have -2. So -2 will 0,
0,
right?
1 by
Okay,
5.
what is this? 1 by
1
5,
by
good.
5.
Yeah,
0, 1 by 5, 0.
0, good. For the other one,
1, 0, 0, 0.
1.
1, sorry, 1 by 5, 0, 0, no, 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 1 by 5, 0, 0, 0, 1 by 5.
So you're saying that, okay, hold on. 1 by 5, 0, 0, 0, 1 by 5.
Yes.
Okay, 1 by 5. Well, you can always, okay, let me think. I think there should be the probability that my x is equals to -2 and my y equals 4. Because I'm getting the 4 from the 2 as well, right? Right? Do you understand this point? Not only do I get so if my random variable
Come
takes on the
again.
value -2, right? I get y equals 4. But when my random variable takes on the value 2, I also get 4, right? So this should be 2 by 5. This should be 2 by 5. Is that point clear?
सर फिर तो y is equal to 1 वाली रो में भी shouldn't it be 2 by 5 and 2 by 5 under x is
No, no,
equal to
no.
minus 1
Okay,
and
hold
1?
on, hold on, hold on. I think I'm confusing something. Let me see. Hold on. Uh, no, 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 no. Perfect. Sorry. Sorry about that. This should be 1 by 5 and 1 by 5. Yeah. Okay. Sorry about that. Okay. Where were we? So what is the total here? 1 by 5? What's the total? 1 by 5? 1 by 5, 1 by 5, 1 by 5. I get 1, summing all these up. These are my marginals, right? For x. Likewise for here, I get 1 by 5, 2 by 5, and 2 by 5. Actually, this is what I was talking about, but never mind. Uh, so these also add up to 1, right? Is that point like, does anyone have any questions? Feel free to ask.
Sir, this question is clear, but can you please explain marginal probabilities, like the concept of it, because I missed the lecture, so I know what they mean by that.
I think it would be, uh, okay, okay, sure. So I think in the next question, you'll get a much better sense of it, and because that's a continuous case. Okay, so I think the idea is this. Okay, let me just. You have a probability density function, right? And from this, I want to construct the probability of like just marginal. It's by definition in the margins here and here, by just so you know. But the main idea is this. From a joint probability distribution, okay, if I want to construct my singular probability distribution, okay, how do I get that? That's the idea. So that would just be equal to, so for example, P of X equals K would just be equal to, if I sum over all the values X and then Y, let's say, has some realizations J. If I sum over all the values of J, right? Obviously, all of these are gonna, like when I sum those up, I get this thing over here. Is that point clear?
Yeah, makes sense.
And likewise for the Y case. But let's just wait a little bit and we're gonna get to that part as well. Okay.
Yeah, thank you.
All right. No worries. These are, by the way, your marginal probabilities, right? So now let's just compute E of X and E of Y. Well, that's what that is. What is this? Just simply minus 2 times 1 by 5, right? Plus minus 1 times 1 by 5. So basically this, that what you're doing here is, hold on. Did that person, okay, just a second. Okay, good. Yeah. So the idea is for the expectation, what you're doing is you're just summing up, right? So -2 is your realization, and the probability that your random variable is X is 1 by 5. This thing over here. Is that point clear?
Yeah.
This is not from the joint one. So this is basically the probability of X, or this thing over here. Probability that x equals 1 by oops minus 2. This is this. It's not the joint probability distribution, okay? Not this thing over here. Is that all right?
Yeah.
Okay. So you do this, and this is just likewise this plus 0 times 1 by 5. Or, I mean, the simple way would have been just take 1 by 5 common and then just add up the random variables. Plus, minus 1, 0, plus 0, then 1, and then 2. This gives you 0, right? Because these are just negative 3 and positive 3. So expectation of y is just 0. Likewise, for the expectation of y, you have x squared. You're going to use now these marginals. So how would you go about it? Well, your random variable now takes on just three values. 0 times 1 by 5, which is so 0 is your realization, and this is p of y equals 0 times this. Likewise, for this, you have plus 1 times 2 by 5. And then again for 2, you have 2 by 5. Sorry, I should write 4 here. Here it should be. So this is just 2 by 5, and this is 4, right? Because that's the realization and respective probability. So what would this be equal to? 0,
2.
2 by 5, and then 8 by 5 is just 2. Okay, good. Let's jump to now the next question. Yeah, okay. So I would want you guys to find the value of C. Please solve it and tell me the value of C. I mean, it's fairly simple, right? You want me to do it?
Sir, I'm solving it. Just a
Okay, good. Good. But for the other people, 1 is equals to, well, you have this, right? This, I'm gonna guess this is for X and this is for Y.